Welcome. This is 8.3, and so we are going to start getting into some trigonometric ratios. So in this unit, a super important unit, we're going to be using this quite a bit. We're going to start getting into some trig right now. So when you hear like students taking like algebra 2 trig, like we're talking about these types of relationships. And what is it though? So we have these three concepts right here. We have cosine, we have sine, cosine, and tangent. So make sure you write this all down. And what we are trying to do is, remember, this only applies for a right triangle. Only applies for a right triangle right here. And these three functions allow us to find the angles of any right triangle. Again, it's got to be a right triangle. But remember, if we had one of our special right triangles, like a 30, 60, 90 triangle, there was a certain way to be able to find the different sides. But now, if we are given the different sides, we can find the different angles that we have right there. So write this down. I want you to write all of this down right here, and there is a shortcut for remembering this though. So the shortcut is this. So write this as well. We call this so. We do ka, toa. So this is an acronym that a ton of people use in order to remember sine, cosine, and tangent, and how to set it up. And so what the first one is, S stands for sine, O stands for the opposite right there. See the opposite, and then over the hypotenuse. So that's how we get the sine right there. The K is, C stands for cosine. The A stands for adjacent, which means next to, and the H stands for hypotenuse. And the TOA, T stands for tangent, O stands for opposite, and A stands for adjacent. Okay. So what we're going to do, even though you have this written down right here, I like to rewrite it in a different way, so I'll come back to this slide in just a second. But let's have you guys write right here. The way I always remember this was I wrote so, and I like doing a fraction like that. And I would do ka, toa, just like that. So I would set it up just like that, and then I would, that's how you write it. So let's write this out just so we remember. So sine, we can abbreviate it as S-I-N, and we don't pronounce it as sin, we say sine right there. O stands for opposite, H stands for hypotenuse. So we have sine equals opposite over hypotenuse. Cosine, which we do COS, stands for cosine, is the adjacent right there over, and that is an H, over my hypotenuse. T stands for tangent, so T is tangent, and that is going to be the opposite over the adjacent. And so these are super important formulas that we're going to need to know. And in order to do these problems, you're going to need to have a handy dandy calculator right here. So in order to do these functions, you need to have a calculator, and let's see if you can see it. See how I have these right here, my sine, cosine, and tangent? You got to make sure that you have a calculator that has those buttons, because without a calculator to do those buttons, there's no way to be able to find the answers. They used to, back in the day, have like a big chart, but we're not going to do charts. You're just going to have a calculator, and a calculator, you're going to be able to put this in and be able to find what those measurements are. Okay, so let's do a few problems. Alright, so our first problem that we have right here says, what are the sine, cosine, and tangent ratios of t? So we are talking about t right here, and remember that these trig things are allowing me to find either the different angles or the different side lengths, and this only applies to a right triangle. So we are talking about this right here, t. Okay, so again, I always, whenever I'm doing these problems, I'm going to write out my SOHCAHTOA. I always write it out. Now, do you have to do it with these fractions right here? No. I see a lot of teachers will do this. They'll do SOHCA and they'll do TOA. Now, I like to do the fractions right up here because that just reminds me that I need to write these as a ratio. Okay? So, the first thing that we're going to do is we're going to find sines. We need to find each of these. My sine right here is going to equal, and remember, my sine is the opposite over the hypotenuse. So if I'm talking right here, my opposite would be 8. So I'm having 8 over, and my hypotenuse, well, that's easy because that's always going to be across from the right angle. That's going to be 17. Alright, let's do a different color. Let's do violet, that's a good one. My next one is, we have cosine. So cosine right here is going to equal, cosine equals adjacent over hypotenuse. Remember, adjacent means next to each other. So if I'm looking at this t right here, well, 17 and 15 are both adjacent. How do I know which one to use? Well, I know that the h stands for hypotenuse, so that means that the h is going to be 17. So when I'm talking about adjacent, I'm talking about the one that isn't the hypotenuse, so that's going to be this 15. So my 15 over 17 is going to be right there, which means that my last one right here is my tangent. So I have tangent right here, and tangent equals opposite. And again, what is going to be opposite of this? Well, we said opposite is going to be 8. And we said adjacent. And again, when we're taking the adjacent one, we don't want the hypotenuse, so we're going to say the adjacent is going to be 15. And those are my 3 trig ratios for angle T. Okay, let's go on to our next one. Alright, so our first problem right here is we want to find the value of W. So first thing I'm looking at this, we know it's a right triangle, so we see it's a right triangle right there, and we're trying to think, well, a right triangle, if we want to find the other side, we know we can use Pythagorean theorem, but I need another side to do that. Well, I also know I can find another side if it's a special right triangle. Well, this one is not a 30, 60, 90 or a 45, 45, so if it's not one of those and it is a right triangle, we can use my SOHCAHTOA. SOHCAHTOA. We can use our trig function in order to be able to find what that other side is going to be. So when we are looking at this right here, we're always going to start with this angle. So we have this angle right here, and we have 2 sides. Well, if I'm looking at this angle from this point of view, well, that opposite side right there is going to be W. So I have opposite. And if I have this right here, which is across from that right angle, that's my hypotenuse. So I know that is h. So I know of these 3 trig functions I'm using, I have opposite over hypotenuse, I know I'm using my sine. Okay? So I have sine equals opposite over hypotenuse. So I'm just going to fill it in. So I'm going to have my sine, and then I'm going to put the degrees that the sine was. Well, the sine was 54 degrees. So it's sine 54 equals, my opposite was W, and the hypotenuse was 17. And so what I'm going to do is I'm going to rearrange this to get W by itself. So I'm going to multiply both sides by 17. And so that's going to give me, these cross off, and this is going to give me W equals 17 times sine 54. And this is where your handy dandy calculator comes into handy. So when I type it in, I'm going to type in 17, and I'll show you a little bit closer. And then I'm going to press the word sine, and then I'm going to put in 54. And so I'm going to make it look just like that. I typed in 17, I put in sine, and then I do 54, and then I can close the parentheses 1. It doesn't really matter though, because when I press equals or enter, it shows me, there we go, it's going to give me this right here where I get 13.75 and a bunch of numbers. And if I round it off though, I know that this other side right here, what W is going to equal 13.75. So the trig function SOHCAHTOA allows me to find other sides and angles. So this one allowed me to find out what that other side was. Now let's talk about the opposite, about angles now. So let's go to our next problem. Alright, so in this problem right here, it says what is angle x to the nearest degree. So instead of finding now one of the lengths of the sides, we want to find one of the angles. So again, at the top right here, I'm going to write my handy dandy SOHCAHTOA. And again, I like to write them as ratios, so I know I need to put those as ratios right there. So I want to find out what angle x was. I want to find out this angle right here. So if I'm looking at this right here, I know that I have that is going to be 6 is going to be the opposite. So I have opposite, and I know that this 10 is across from the 90 degrees, so that is going to be my hypotenuse. So if I'm looking at which one of these three, sine, cosine, or tangent, well, I'm using sine in this one. So I'm going to use sine in this case right here. And so let's erase this. And remember, we are trying to find one of the angles. So we're trying to find out this angle right here. Let's call this angle A. Let's say we call it angle A right there. Okay? We're trying to find out what angle A is, that angle right there. So let's say I would write this. I would write sine. Remember, whenever we write sine, we always want to have our angle. Well, we don't know what that angle is, so we're going to say that is going to be angle A right there. But we know right here that the opposite was going to be 6, and the hypotenuse, which is across the 90 degrees, is going to be 10. Now I want to get this angle to be all by itself. So what do I need to do? Well, normally I would divide both sides by it, because I'm taking the inverse. So when I take the inverse of this sine right here, what I am really doing right here is, let's use blue, I like blue, is we're going to take the inverse. So the inverse of sine would be sine, and with this little -1 right there. So we are going to take the inverse. That is my inverse right there. So what that happens though is sine, the inverse of sine and sine, basically these cross each other out, and we are left with just angle A, which is what I want. And what I do to one side, I have to do to the other side. So I'm going to take sine -1. So again, I'll blow this up. I'll make myself a little bit bigger right here. Let's see if I can do that. Let's go medium. Alright, if I'm doing right here, I have my calculator, and I'm looking at it. Do you see, let's see if I can put it right here. Do you see I have my 3, sine, cosine, and tangent. And you see right above there, I have that sine to the -1, cosine to the -1, and tangent to the -1. Those are my inverse function. So what I'm going to do is, to find angle A right here, I'm going to take the sine, my inverse sine of 6/10. So when I plug this into my calculator, I'm going to go to that inverse sine, so I'm going to get that -1. To get there, I just press my second one and that sine in order to get there, and I'm going to put 6 divided by 10. So it looks like this so far, and then when I press equals, I see that I get 36.869. Let's just round this to 36.87. So I know that, let's move this out of the way. I know that my answer right here, angle A right here, angle A is going to equal 36.87, and let's just put that in degrees. So that allowed me to find out what that degree was right there. Alright, let's do uno más, one more. And I'm stuck. How am I stuck? Let's see. Pause. Oh, I see. I can't pause the video. How do I? Got it. Alright, sorry about the technical difficulties. Let's get to my last one. My last one right here, and we'll go a little bit quicker right here. So this says, use the figure at the right, and we want to find out what the angle of measure y is. So I want to know what that angle is right there, and we want to find it to the nearest degree. So if I'm looking at this right here, what do I have right here? Well, I want to write, again at the top right here, my SOHCAHTOA. I'm going to write out my formula, and I'm trying to find out the angle. I don't know if it's 30, 60, 90, so I can't use that, so I got to use one of my trig functions right here. And so I'm looking, well, what do I have? Well, if I'm going from this angle right here, I know that I have my opposite over, and this is right next to the angle, and it's not my hypotenuse, so this is going to be my adjacent. So I know that I'm using tangent. Tangent right there is what I'm using. So again, I'm trying to find the angle though. So I'm trying to say, let's say that this angle right here is angle A. Okay, angle A right there. We're trying to find out what angle A is. So I would take tan of, we'll say, let's call this angle A right there. And we know that my opposite, well, the opposite was 100 over my adjacent, which is 41. And so again, we want to get this angle all by itself. So how do we do that? Well, we have to take my inverse. So I'm taking my inverse of tan, which is tan to that -1. That's my inverse right there. So that crosses both of these off and leaves me with just my angle A, which is what I want. And what I do to one side, I have to do to the other side. So I put this into my calculator. I got to take the inverse of tangent, and I do got 100 divided by 41, and again, it should look something like that. Tangent to the inverse of tangent of 100 divided by 41, and we're going to get 67.706, and it says round to the nearest degree, so we're going to say that this right here is going to be 68. And remember, we are talking about degrees, so we're going to put a degree mark. Boom! Done. Alright, we'll practice more. If it sounds kind of confusing, with practice, you guys will be awesome at this. Alright, we'll see you guys soon.